by clicking the raise hand button. And that is the person instead of Oboh.
Excuse me, all. Is it only me? I can't hear the presenter.
Hello, can you hear me?
You were muted.
Oh, I think somebody did that. So that's very. Can you hear me now?
Yes. Can you make somebody else co-host just in case?
Oh, okay.
Like you did, because you're not sharing your screen anymore.
Oh, wow. Okay, can you see the screen now?
Yes.
Okay, thank you.
Yes.
I'm very sorry for that, the breaking transmission. So I want to introduce.
Thank everybody, who showed up. And I can see some of my current students and my mentors. And I'd like to call out especially Professor Showumi. Good afternoon, Ma. And thank you for the role you've played in my life, for encouraging me on. Okay.
Francisca.
Yeah. All right. Can you all see my screen?
Yes, I can see it, yes.
Okay. All right, so again, it's good morning from here. It's just after 8 a.m. here in Missouri. And so it's been a long journey, but I thank God for where I am right now. And just for the next 40 minutes or so, we'll share my perspective on this field called palynology, which is not quite well known compared to other disciplines. So the outline of my presentation today will be a brief overview of the discipline itself, and then I'll present 5 case studies and try to be as fast as I can to explain how powerful a tool palynology is. So I'm going to run very briefly because there's a lot of geologists and even botanists that I meet. They have no idea what we do for a living. So palynomorphs are microscopic structures of organisms which tend to have organic wall that tends to be very highly resistant to decay other than oxidation. They're usually small in size, derived from the 5 of the 6 kingdoms. I'm not using domains here, which is the new classification scheme in botany. In biology as a whole, range in age from Proterozoic to Holocene, can be found in all types of environments from non-marine to marine, which makes their utility for correlation very good. There are multiple applications, not only in geosciences, but archaeology, medicine, forensics, and so on and so forth. So the major categories include acritacs, which tend to be mostly, they used to be marine until later on in the Quaternary, single-celled algae, chitinozoans, which we now know are related to some protists. These usually tend to be larger sized, dinoflagellate cysts. Most people would know these as being responsible for red tides in oceans, but we do have non-marine varieties now. Scolecodons, which are the organic mouthparts of marine.
Dr. Franca, your screen is not being shared.
Okay, let me go back again. I was sharing this. Let's see. It's been disabled again. So can you please enable screen sharing again? Can you make me a co-host if that would help?
Do that, but I think you are now the host.
Okay. So let me share this again. I don't know where I was when the screen sharing stopped.
At the overview.
From the outline.
Or was it from the outline? Okay, let me go back.
Yes.
All right, so to the major categories. The acritacs, which I have already talked about, you did hear me talk, but so here was where I stopped. The microforam linings, which are the inner organic tests of foraminifera. They tend to be smaller sized than the main organisms after the mineral walls dissolve. We find all of this in our palynological sediments. Embryophyte spores, some of which can be megaspores produced by ferns and some of the lower plants. Pollen. When we use the word palynology, this is what comes to mind to most people. That is pollen analysis from the male gametophytes of gymnosperms and angiosperms. We also find microscopic algae and algal parts in our sediments. This is Botrococcus, which is found mostly in freshwater and brackish environments. We have what we call cryptospores, which have now been found mostly in Cambrian and Ordovician sediments. Some see as maybe precursors to land plants. We have algal spores and other fungal bodies. I cannot talk about palynology without mentioning particulate organic material. Some call this palynol debris. These we find all over our sediments. They're just organic remains of different plant parts, animal parts, all help us with our analysis. So I'll move on with the case studies. These are the 5. 3 of these I have been involved in, but 2, the late Professor Von Bryant, who was another mentor of mine from Texas A&M, gave me and my students these 2 case studies. One is melissopalynology, a case from East Texas, and then forensic palynology, showing examples from New Zealand and Pakistan. Sorry, I seem to be going back. So the very first grew out of my sailing on the ocean drilling program on the JOIDES resolution in the 90s. And we drilled in the Atlantic Ocean off the coast of Ghana and Cote d'Ivoire. And the idea was to understand the separation between Africa and South America and the evolution of the Atlantic Ocean and the sedimentation since then. So 2 of the major publications that came out I have listed here. And it shows here the sites where we drilled. There were 4 sites, and with a lot of the transform faulting in that area, we were able to understand part of not just the sedimentation history itself, but the paleoceanography. But the most profound experience for me was learning how to collaborate with people and also learning how to be patient when you are on the ship for 8 weeks and one of your colleagues does not shower every week, maybe once a week. You learn how to be patient and not to throw somebody overboard because of that. So this shows, for example, I mean, it's very busy, but the dinoflagellates were the ones that gave us the key. The main reason I was actually chosen to go on this was because I was a palynologist. Most of the sediments were black shells. So there were no planktonic foraminifera. And one of the goals was to find the KPG boundary. And while on the ship, one of the main focus, the main polynomorphs that I was able to use was Tinal andrevi. So it was spores and pollen. And it was after the cruise itself, we were able to process for the dinoflagellate cysts. So we have all of these, which in this particular slide shows the most of these polynomorphs. So we have here some of the markers that helped us define this boundary. Interestingly, benthic foraminifera back this up.
Prof, sir.
Okay, so here's some of these significant that we use. So we use this. Can you mute, please?
Can you mute from your own hand? Can you help us mute Engineer Farmer DG, like you have the host?
Okay, let me try and mute.
No, I think Prof is the host now.
Yeah, I'm trying to mute.
Yes. Engineer
Please
Farmer.
go
Yes, please.
Okay, but anyway.
Sorry for that. So
that's all right. Yeah, so we were able to use many of these to understand the biostratigraphy. In addition, we did do some paleoclimatic and paleo-environmental studies using the polynomorphs. So it was a great study. And again, those collaborations are still going on. So I'm moving quickly to the second one, and which this grew out of my Fulbright scholarship to Egypt as well, and also an NSF grant, the National Science Foundation. And the focus here was on the hydrocarbon potential of the Razak field in Northwest Desert in Egypt. So this is a very prolific petroleum province in Northern Africa. So the Razak field is right here. And in this particular slide, it shows the paleogeography during the Cretaceous, because that was at the time the sediments were laid down. So there was transgression in that area. And it shows the approximate location of the Northwestern Desert. So what we were trying to seek here was trying to understand why we had some of those black shells, and to see if we could recognize the oceanic anoxic event 2, which is called the Bonarelli event, had not been recognized in that particular field. And within the Western Desert, I think only one study at the time we did this had been able to do that. So we can see the Cretaceous interior seaway, which was in Northern America, and then Northern Africa had a lot of transgressions. And in fact, down south into Nigeria, we had transgressions taking place at the time. So I will have to stop here. Somebody is requesting to record locally, and I'm going to deny because it's not in my place, okay? So we find that the peak organic richness and the black shales, which occurred from west to east, were also resulting from upwelling along the Moroccan Atlantic coast. And in the eastern part, we did not see that. So what did we find? So we have here a generalized upper Cretaceous lithostratigraphy of the area. So our focus was on the Abu Rawash formation and the Bahariya formation. We were seeing these organic rich sediments in the G, F, and E members of the Abu Rawash. Very, very outstanding. And they were quite, not only, they were not really clastic, but mostly carbonaceous. So organic rich carbonaceous sediments. So we did, the focus here was not only on the, so on the palynofacies. So it shows the terrestrial palynomos. We use just 6 categories here: the opaques, phytoclast, and then the marine palynomorphs, and then the amorphous organic material. And we were able to actually delineate 2 segments within these organic rich sediments. And so at the bottom, we had what appropriated with the type 1 kerogen, which tends to be oil prone. And then at the top, were mostly phytoclast. We didn't have much AOM, and types 2 to 3, all to gas prone. These show some of the diagnostic palynomorphs we found. And on the left-hand side here, and then on the right-hand side here, palynofacies. Okay, it's kind of difficult for me to know who is speaking.
Hello, Dr. Agbala Jobi, please, can you unmute? Can you mute yourself, please?
Okay, thank you. So in this particular study, we integrated palynology with organic geochemistry and ran the same samples for organic carbon, delta 13, and the total organic carbon. And so here, we've integrated the palynofacies with the organic geochemistry, and we were able to recognize this OAE interval. So looking onto the paleo environment, those 2 sections that we found, the lowermost section was very rich in amorphous organic matter. The palynomorphs, the marine palynomorphs, we think is showing here is absent. What we suspect was that they were not well preserved, or even those that were preserved were covered by the amorphous organic material. The total organic carbon values were quite high, and we did not find freshwater algae. But then where the phytoclasts were very dominant, we had a lot of freshwater algae and a little bit more of it terrestrial palynomorphs, and the amorphous organic matter and total organic matter components were much more reduced. So the environments were marine, but we recognize a shallowing upward. So in this area where we had the non-marine palynomorphs and the terrestrial organic matter was a shallower condition. So the deeper marine environment was where we saw most of these organic rich material. So this is one other way in which palynology can assist. Okay. Now I'll move on to the 3rd case study from Professor Bryant. And the example he used here was pollen in honey in East Texas. This is melissopalynology. Here's Professor Bryant trying in his beehive. So he kept bees also. So essentially, what this tells us is that when we are looking at pollen in honey, it's one of the best and least expensive methods used to determine the true origin geographically and also the sources of nectar. So this is one part of palynology that is not commonly known. So we find that if there are several types of honey and they are blended, the pollen can immediately reveal that the sample is a blend. And Professor Bryant was always telling us how he was invited to actually sample the ones from the White House. This was during the Obama era. And he was able to let them know that their honey was not pure. So the types of pollen will also be clues to identify the origin. So this is East Texas. So these are just different types that are found in that region, like mimosa, sweet clover. Many of us are used to the clover honey, dogwood, which incidentally in Missouri, that's the state flower. But we have to take this with a grain of salt. So when you are testing the honey, we find that it can be misleading if the person doing the testing does not consider the following points: that the percentage of the pollen and the percentage of the nectar from each pollen source in honey is not a one-to-one relationship, because this is one of the major errors that is found in this study. So the accurate identification of both the nectar sources and their importance requires knowing the expected amounts of pollen for each type. So let's look at examples here. So what's the expected average in a pure unifloral honey? So in this case, there's just a single source. There's no blending. So these are some of the standards used. So let's start with fireweed. In this case, per 10 grams, you're going to find 1,000 grains of pollen, which is low compared to others. In sage, sage is one we use for, it's a herb which is often used for cooking and all that. We have 4,500 grains of pollen per 10 grams. In star thistle, 9,000 grains of pollen per 10 grams. In sourwood, 10,000 grains. So you can see here the values going up or less per 10 grams. In manuka, manuka honey is one of the purest types you can find if it's not blended, more than 2 million grains of pollen per 10 grams. But then look at forget-me-nots, 150 million grains of pollen per 10 grams. So without knowing what some of these expected averages, this type of study may not yield the correct results. My fourth is also from Professor Bryant, and this is forensic palynology. And this is one of the hottest new areas in our science. So pollen is being used in crime scenes at various, and here I'm using 2 examples from Iraq and also New Zealand. So in this case, pollen and spores are kind of fingerprints of plants. So depending on where you are, you have different kinds of vegetation. These are examples from the United States. So each area is going to produce a unique pollen print. So we have the Appalachian Mountains here. You can see it's densely wooded, all along the eastern seaboard of the United States. And then you go to Arizona, like the Four Corners region. It's a desert. You're going to find a lot of cacti. End up in Kansas, it's a prairie, it's grasslands. Or you go to British Columbia. Here, where you have the mountains, you're going to have a different kind of vegetation, which is definitely different from all the others I have highlighted here. So this is also Professor Bryant doing some of this work. So with the pollen, both the identification and interpretation can be done quickly using light microscopy for forensic samples. You don't even have to go as far as using the scanning electron microscope. So it's a rapid type of analysis just to give investigators an idea of what type of vegetation is in a crime scene. So this actually was pioneered in New Zealand in the early 1980s by Dallas Mildenhall. I think the next slide is going to show him. So the focus was on a case that involved the theft of deer antlers for velvet, which sells for a lot of dollars in Asia. So these show some of the reason why the antlers are important, because they get extracts that support quite a few of these things: heart health, muscle building, and for those who are injured during sports. So here's a list of some of these, like repairing cartilage that are damaged. So Dallas Mildenhall was the one who was approached to study the palynology. So the primary focus in New Zealand, and he had investigated over 200 cases since 1981. And so the law enforcement personnel continue to use this now as evidence in most crime scenes. So almost every kidnapping, murder, theft, illegal drug, and rape is subjected to forensic pollen testing in New Zealand. Here in the US, the FBI actually has a crime lab right now, and the crime lab has a full-time palynologist in Chicago who is doing their study. So here was a case in Iraq where there were 3 suspected Al-Qaeda agents who had been, they had been caught, and they each denied that they knew each other. But each of them had a sleeping bag, and that they claimed they were not even in the same location. So what happened was the pollen samples were collected from all the bags and analyzed. And the evidence confirmed that all 3 sleeping bags had been in the same place, in the same mountain region in Iraq. The interesting thing about the forensic palynology is that the palynologist who is analyzing the sample is not told where the samples come from. So they work blindly and then give their results. My final case study, and then I'll be done. It's work I did in Australia. We started this work in 2005. Went back twice because we were funded by the National Science Foundation. So initially we went just to study surface lake sediments in the salt lakes to understand the dynamics of lake processes, but went back to drill into the lakes for paleoclimate and paleovegetation analysis. So our focus was in Western Australia. We initially visited Victoria, north of Melbourne, but later went back to drill in Western Australia. So we have in the southern part, a lot of paleo drainages. So they are dry today, but when you look at the satellite images or the GIS images, you would see lakes aligned in what appear to be paleo drainages. And we studied lakes in the Cowan Basin as well as the Avon Basin, right here. This is what they would look like. And all these white specks are actually salt. So these are lakes where salt are actually being deposited. I remember when I was an undergrad, I always thought that salt was produced only in the ocean. But when you go to Australia, you see that you can have salt being precipitated inland in inland lakes, but they all needed to have had a supply of salt for this to have taken place. So I'll explain this further. So here is the Yilgarn Craton and the 10 lakes we studied. We actually had the privilege to name most of these lakes because they had not been studied. And for example, we have here Prado Lake. Anyone who knows Toyota Prado, that's what we named it after because we rented Toyota Prado Jeep. So we named this particular lake Prado Lake. Here was Gastropod Lake because we had dead gastropods all along here. Twin Lakes because there were two lakes separated by this great Australian highway from Perth to Adelaide. We have Lake Brown, which is one that is well studied in the Avon Basin. The Cowan Basin itself, Lake Aerodrome was one we named because there's a small airstrip around it. So we looked at these 10 and decided to go drill. We went back in 2009. The first time we went was in June, which is the Australian winter. So the lakes were flooded and they had a very wet spring. But when we went back, it was now January, which is the summer in those areas, and the lakes were dry. So what did we find? We had come up with this conceptual model based on our initial trip that there were different kinds of lakes that we found, 3 main types. There were some lakes that were resting directly on the basement rocks. And then there were some that were actually resting directly on the sediments, and these were deep. And then there were others that were quite shallow. Okay, so there were lots of microbes in these lakes because hardly any life because they were acid saline lake. The characteristics, very shallow, less than 20 centimeters in some cases. I don't swim, but I was able to go into these lakes. So the water came to your sometimes your ankle or maybe your knee. They were ephemeral with pHs that were mostly 1.5 to 4. These are really acidic. I mean, 1.5, if you had a wound, it would sting you. We found sodium chloride, halite, and gypsum precipitating. In some cases, just randomly, one lake would have sodium chloride, another lake 10 kilometers away would be gypsum. It was red everywhere. You would think you were on the planet Mars. And then there were low growth vegetation and trees all around. So what we found was that there were 3 stages. So whenever it rained, it was flooded. And then you had the evaporites in the lakes would dissolve or partially dissolve. And then would come an evapoconcentration stage when your minerals would start precipitating. And then the desiccation stage, I mean, look at the actions of winds, everything evaporates and all you have left to be just your salt. During evapoconcentration, there's still some water, but it's reduced. We were able to observe these processes on both trips. So here's Lake Brown during 3 different field seasons. This was flooding in September 2011. This was evapoconcentration, January 2008. This was desiccation, January 2009. This was when we went back to drill. It was totally dry, same lake. You have all the eucalyptus trees around, but this was the most profound we found in January 2009 during our drilling. It rained early in the morning. So this is Lake Aerodrome. So there was water. By noon, the water level had really shrunk. There was evapoconcentration. By 4 p.m., this is all within 8 hours, the lake was dry. So this tells you that you can have these extreme changes. So it kind of set us up to understand that when we were going to drill, even if we found a continuous core, that core may not be representing continuous record because you're going to have those breaks. So this was a drill rig. It was a rotosonic drill we used. This is right in the middle of Lake Brown. And this drill rig did not use drilling fluids, they used water instead. So we had two types of settings here. There were lakes where we could only get 2 to 25 meters of sediment. Okay, and there was Lake Aerodrome was the deepest, where we got nearly 60 meters of sediment. And here at the bottom, we ran into coal deposits. Today, Western Australia is a semi-desert, very dry. And it shows the kinds of sediments that we were able to recover. Lake Aerodrome has gypsum. These are gypsum, sawtooth gypsum crystals. Lake Brown has a lot of halite. Okay, so what did we see palynologically? We found that for spores and pollen, we were saying like pollen with dry affinities were higher above 40 meters, especially this is today. Prior to our visit, we were told we would not find anything because no pollen or spores had been recovered from the red sediments. We found a few, but those with wet affinity dominated where we had coal and shale, 40 meters and below. Some of the ones we found here, we knew where it worked. So here, some of these we think got here because of caving during drilling. These were reworked because most of what we saw here was Botryococcus, and we'll see examples later. So the most profound, I would say, finding here was finding an extremophile called Dunaliella. This is a green alga, which is only found in very extreme environments. We found Dunaliella above 40 meters in the sediment. Botryococcus was below. This we know is freshwater to brackish. Dunaliella is found only in extremely arid and hypersaline environments. So this told us something here, that we're up to something. But we found reworking also. Here we had nothofagus. You can see these are all beat up in Lake Brown. Botryococcus I showed you earlier was beautiful. This is what it looked like here. And then we actually found marine palynomorphs in Lake Brown. The last transgression in this part of the world was in the Eocene. So obviously these were reworked from the marine sediments into Lake Brown. But it also brought up something else. In 1981, Bint actually noted that there was like freshwater environments during the Pliocene because he found some well-preserved palynomorphs that were of freshwater affinity. We were able to now come up with, and he suggested there was a refugium during that time. So this was the Metasidites lipsis zone, which we found in our sediments. But we think that it was actually reworking that he found. And of course, there was no marine influence since the late Eocene. So the reworking we see in the Miocene to Holocene sediments were from the late Eocene Werilop Formation, where we had coastal swamps and temperate forests. So this is where we saw the coal and the shale deposits. This is what we were able to find in those sediments, and this is what we found in the upper sediments with the reworking. So this is the same species, looks like this. This is Botryococcus, this is what it looked like. And then we found the evidence of dinoflagellate cysts. So I'm about to round up here. So evidently in Western Australia, the highly dynamic sedimentation affects not just the lithology, but also, in our case, the particulate organic matter, including the palynomorphs themselves. So post-Eocene, we had the arid conditions and the wetter conditions during the late Eocene. So the reworking was, we saw that evidence. So we find that the refugium that was reported was not a refugium, but reworking, and then we had dry hypersaline conditions from the post-Eocene to the modern times. And that's where I stopped my presentation. I hope I did not go over. And thank you so much for your attention.
Thank you very much, Dr. Franca. We're very sorry for the interruption during the course of your lecture. Unfortunately, please, Abiodun Jones, can you mute yourself? Abiodun Jones. So we're very sorry for the interruption during the course of your lecture, but we really appreciate you for this very stimulating lecture, and it was brilliantly presented. We really appreciate you for coming around. We thank you for your time. And I believe people, now it's time for discussion, it's time for questions. We can make use of the Zoom chat, or we can raise up our hand so that we can ask questions. I can see someone raising up his or her hand. Please, can you?
Showumi.
Oh, Professor Sowumi, please, you have the floor. Professor Sowumi.
Yes. Thank you very much. Good afternoon, everybody. And thank you very much, Francesca. That was a very brilliant presentation, and it's an excellent overview of how global the application of palynology is. Of course, it's the excellence is as expected, but we are very proud of you. Maybe because of the interruptions, Francesca, did I miss any Nigerian example?
Yeah, you did not.
Did you hear me?
You did not. No, you did not. I did not show one.
Because I was thinking charity begins at home. Even though it doesn't end there, but charity begins at home. I thought you give us some of your own work or some other Nigerian palynology. So next time you are giving this kind of talk elsewhere, you must put Nigeria.
Prof, well noted. Thank you. It was an oversight. Prof, can I see your face? I haven't seen you in a while.
It was very, very interesting.
Prof, can I see your face?
Okay. I know I'm not. Yeah, I'm trying to put my video on. I'm not very presentable at the moment. Let me see. Okay, it's going off again. I'm trying to start my video, but it keeps on crossing it out.
Oh, I can see you.
Can you see me?
Yeah, it's good to see your face, man.
As I said, it's just rushed down to join. Yes.
So well noted. Well noted.
Very well.
Yeah.
And I like your braid.
Oh, thank you.
Inside. I like your braid very much.
Thank you.
Yes. Thank you so much. Thank you for the way you are projecting Nigeria globally. We are very proud of you. Thank you.
So, Prof, thank you very much. And
thank you. So next time you amend that though.
I'm going to embarrass Prof. For everyone who does.
Nigeria is part of the world. You are welcome.
Prof was my external examiner for my master's degree.
Wow.
And she made me cry. I cried, but from crying, I was able to correct my master's thesis and get two publications out of it, because she grilled me and made me cry, but that's what made me who I am today. And Prof always came to Cambridge to visit me when I was a student. She visited with me twice, and I'll never forget. Thank you for your support, man.
That's frozen.
Mama, Professor BC Sowumi, we really appreciate you for gracing this occasion and also for your contribution. We really appreciate you, Ma. We are glad to have you in our midst this afternoon. Thank you very much. Do we still have any question or probably, okay, I can see Professor Benga Enhiola. Please, you have the floor, sir.
Well, that's an excellent presentation. I congratulate the speaker today. However, you talked about paleo-vegetation and paleoclimatic. I don't see any of your presentation on that. Are they work in progress?
The paleo vegetation and paleoclimate was the last case study I tried to highlight for Australia, was where we were able to note that during the Eocene, it was much wetter, it was warmer, and that's why we had the coal deposits. And then we were able to see that the vegetation included like those with wet affinities, and it was like a coal swamp. And then post-Eocene, especially today, that's where the Dunaliella, the alga, came in. So we have hypersaline conditions today. It's much drier. And we are seeing a lot more like xerophytic type vegetation in Western Australia today. So again, because given the time constraints, I tried to rush and not give too many examples. So that was the last case study that I used to highlight those two. So did I answer your question?
Yes, very well. Thank you very much. I appreciate it.
Okay.
Okay, I don't know.
Thank you very much, Professor Benga Enhiola. We also have someone in the house, Dr. or Professor Peter Adeonipekun. Please, you have the floor.
Thank you very much, everybody. And thank you, Professor Franca. It was a very nice, well-delivered presentation. I'm particularly interested in or fascinated by your presentation on the pollen in honey, where at least you've shown to us the importance of having a known quantity of honey, volume of honey or gram of honey, and relating to the number of pollen you expect from such a honey, so as to be able to identify them and know their authenticity. So, which is one of the things we are working on in Nigeria now, trying to see how we can work better so as to assist in identifying the genuineness of some of these honey that are sold in the market. So I think it's a very interesting thing, which I'm going to try and reach out to you later after this presentation. Another important question observation or question I want to say now, let me read it as a question, is about what is your view or current trends with respect to pionomorphs being used for sequence stratigraphy? What's the current, from your perspective now? You are there. What is the current perception about it? Thank you.
I guess I was one of the first people to actually start doing that in the late 80s. I think the view is still there. It's just why we haven't been seeing much about that, because the oil industry, many of them have closed their labs, and now they contract out so many of their jobs, to contractors. My view on that is that palynology is a very useful tool for sequence stratigraphy. And not only is it useful, it's very rapid and very, and can easily be correlated with others. So I don't think that view has changed much. Probably maybe to see more publications on it. So it is very, very useful. In some of my work, we're able to actually pinpoint like the transgressive systems tract by looking at just even pollen, not even dinoflagellates, where we had concentration of certain types of pollen here in the Gulf Coast. We're able to correlate that transgressive systems tract with sedimentology and other techniques used. So it is a very useful tool.
Thank you very much.
Okay, thank you very much, Professor Adeonipekun, for that question. I saw Mama Umeji. I saw her. She raised up her hand before. I don't know if she's still around. Mama, are you still around? Are you still with us? Okay, if there is, okay.
You see well.
Oh,
She raised her hand.
yes, ma. Please, you have the floor, ma.
Thank you very much. You know, you talk of Franca, talk of Professor Showumi. Umeju will likely be by the corner smiling. I have claimed that Professor Showumi, that I am the first, I belong to the first of her children. I am not second or third generation, because it was her work that made me a palynology in my university. And I was wondering whether it's a final year student undergraduate speaking, or whether it is the Franklin she's transformed. Thanks for this erudite presentation. Can you hear me?
Yes, we can hear you.
Okay. My comment, mine is not a question, rather a comment. That this honey and using pollen to tell about honey, and also in a forensic studies, is for those, that is those working on recent Nigerian security, use it, because it will be very, very, it is very useful. But for those that are in stratigraphy,
you're cutting out, man.
A lot of Nigerian said you don't have marine fossils, saliferous is not, but you can just not do without palynology. Palynology is the bridge cuts across land and the sea. And we are, those coming behind, we must number of practitioners of palynology, so that they will do a lot of work, sorting the ages of the Nigerian sediments for ease of correlation. And when that's
Very unfortunate that
correlation, you find that geological exploration. And we are, so thank you.
Okay, thank you very much. Yeah, we didn't quite get all you said because it was cutting in and out, but thank you so much for your comments, Prof.
Thank you. Thank you, Mama Umeji. We really appreciate that contribution. We also have some people raising up their hand. We have Professor or probably Dr. Sheyi Ogunjobi. Please, you have the floor.
She is no doctor or no professor. I'm Mr.
Oh, okay.
Yeah, it's nice. I'm not a palynologist, but I have so many colleagues who are Benga Adeonipekun, Benga Hinola. They're all my colleagues in UI those days. Thank you very much, Madam Francisca. I'm sure you won't like that, Madam title, but it's nice to listen to you, and it's nice to see your face. We banter a lot on GeoTrex.
You're very stubborn. That's all I can.
I know. So I wanted to make some few comments. I live in an environment that sounds like everything you've painted. We have hyper saline salts. We don't have sodium chloride here, but we have gypsum a lot. Almost all the sediment around my house, you can literally pick gypsum out. What we do know is that it's an enclosed basin here, Southern California, such that there's a lot of evaporation in the ancient period. Mostly Paleocene to Miocene sediment here. And the story was that there's a bit of oceanic incursion around Miocene. Eventually, the ocean moved away to where it is today on the Pacific coast. So you said most of your oceanic species you've seen are rework. Could it be that there were oceanic incursion or something like that? I'm just throwing anything out there. So that's one. The other thing is that you mentioned eucalyptus tree. Eucalyptus is very common here as well. The reason people plant it is that eucalyptus actually take salt from the ground. So farmers plant it around so that their water can be less saline than it is. And lastly, my question now is that when I go to the supermarket and I want to buy honey, are you suggesting that the more pollen grams there are, the better the pollen? I mean, for just a consumer point of view, and that's my question. Thank you very much for your presentation again.
Okay, Shay, I'll start with the last one. So it's like, it depends on the source, okay? It depends on the source. If it's Manuka honey, which you will see, they tell you it's pure Manuka honey. Obviously, it will have like 2 million pollen per 10 grams, right? And it won't be blended. So it all depends on the type, right? Okay, so we saw that some had not enough. Okay, so the type, like Manuka is one of the best. Okay, so, and they're usually more expensive. You asked the question about the transgression. The transgression I was talking about reworking was specific to Western Australia. So Western Australia today is an enclosed inland basin, but there was transgression during the Eocene, and then the ocean moved away. But then all the depressions created during that time, the remaining ocean water, that was the source of the salt. So even though it was now enclosed and terrestrial, the groundwater became saturated with salt. So in the lakes today, we are seeing those dinoflagellates that were Eocene. So evidence is that when there was sedimentation, the Eocene sediments were reworked into the present day ones. So transgression doesn't necessarily mean that it's reworking. So where you live, Bakersfield, I'm very familiar with that area. I've done some work for Chevron there on the Miocene. So there was transgression, and then you have diatomites off the coast and all those areas. So the sediments you see that are Miocene, they are actually evidences of the transgression. So they are not reworked, okay? So that's a different situation. Now there was a third question, I've missed it. What was
just
the
talking
third
about, no, it's not a question. I was just saying that the environment you presented sounds very, very similar to
Okay.
Bakersfield and Southern California.
Okay.
And you're welcome to stop by the next time you are passing by here.
Oh, definitely, definitely. I'll hit you up on that. I love your drone pictures. I'll be using them to teach. So.
Oh, that's, thank you very much.
Yeah. Thank you.
Thank you, Mr. Ogunjobi. We really appreciate your contribution. Okay, we have two more. Okay, like someone was raising her hand that she's no longer there. Okay, let's have Dr. or probably Professor Lajide Ajayi.
Okay,
Sir, you
thank
have
you,
the
sir.
floor.
Yes, sir. Thank you very much. I'm Prof. Ajayi from AAU of Ibadan, State, Nigeria. We really appreciate the beautiful presentation, though I joined a little bit late. But the reason for my inquisitiveness has to do with the relevance of that research to forensic studies or forensic medicine, as the case may be. That considering times like this, when we have the spread of various infectious diseases and other vices. So I think the presenter can just help us to tell us specifically the areas by which the research can be used as a tool for forensic investigation and other related industrial applications. Thank you. Just to be concise, please, because of time.
Okay, so I mean, for forensics, normally what would happen is like the law enforcement would take, it could be the suspected or the suspect's shoe, right? So what they will do is they will take the shoe to a palynologist and tell the palynologist to take the soil from underneath the shoe and examine the soil. So the palynomorphs from that soil will give them an idea of the vegetation of that area. So if the person is denying that they were there, that would nail them and show that the person was lying, okay? So sometimes they could be from clothing, where you can wash up the clothing and then you try to find what's in there. So that's how that plays out. But in most cases, they will not tell whoever is examining the sample where it came from. So it's kind of like a blind study. Does that make sense?
Yeah.
So I don't know if I was able to
Yes,
answer
sir.
your question. Yeah.
Okay, thank you.
Prof, for that contribution. And then we also have Professor Gbadebo. Professor Gbadebo. The line is breaking, sir. It's breaking.
Can you hear me?
Okay, yes, now, yes.
Yeah. First of all, I want to congratulate Professor Francisca Oboh for the beautiful presentation. I went through the same route like her. I was trained by Professor M.B. Salamin, and also coincidentally was also examined by Professor Mrs. Showumi. My question this afternoon is that, Prof. How have you been able to integrate? Because you were introduced to us this afternoon that you are a professor of palynology and geophysics. So how have you been able to integrate your studies in palynology with geophysics? Thank you.
Okay, so the way we are classified here, my program is geology and geophysics. So the university is going to classify me as a professor of geology and geophysics. In fact, the university system, we have a four university system here. The official title for me is Professor of Geology and Biological Science, because I actually have 25% appointment in biological science here on campus. So with the geophysics, I mean, like I said, it's just a title, but I've worked with geophysicists. And so in that case, it's like my palynology is just a tool for whatever they're doing. So again, the title is just what it is, a title. I'm not a geophysicist, I'm a geologist. But I've integrated my work with geophysicists and other people.
Thank you very much, Professor Gbadebo. We really appreciate that contribution. But before we go today, we have some comments on the chat section, and I'm going to read, and after that, I will invite the NMGS Ibadan chapter chairman to close us, to give a closing remark. But before then, let me quickly read from Ado Mongo. Great presentation. Thanks for the educative section. Then we have from salaulami@yahoo.com. Very insightful presentation. Then from Fashion, great applications of palynology. Thank you. Then we have from salaulami@yahoo.com says, mentorship should not be seen as punishment, but as efforts to make you a better candidate. Thank you, Prof. Then also, thank you from bringing up entrepreneurship skills from this presentation, ma'am. Oh, that is from, okay. Okay, we also have, I think one of our fathers, among our fathers, in the, Mr. Jim Orife. I will call him Elder Jim Orife. Do we still have the father in the house? Papa Jim Orife?
I'm still here.
Oh, can you say something, sir? I think you'll be raising up your hand. Very sorry about that, sir.
It's all right.
Yes,
my comment is the professor did some work in Egypt. And during that stint, she showed a graphic or illustration that showed an incursion of the sea from Egypt down through Nigeria to the Atlantic. I don't know whether she recalls that graphic. If she does, I want to ask a question. Given the work being done now in the Benue Trough, Chad Basin, and Upper and Lower Benue Trough, it would not be nice to look at the relevance of palynology to establishing a cause or a link from Egypt down to the Atlantic to the Benue Trough?
So,
do you get my question, madam?
Yeah, I know what you're saying. So, I don't know if you are aware of a study that came out in 2018 or 19.
I'm not aware.
By Edegbai, Joel Edegbai et al. Joel is he's a lecturer at the University of Benin who spent 9 months in my lab on a Fulbright internship. He was studying, I think, the northern part of, is it the Benin Basin or one of them? And that study, it came out in Journal of African Earth Sciences, was trying to establish that trans-Saharan seaway. That's what you're referring to.
Yes.
Yeah,
yes.
It's a trans-Saharan seaway. And he actually, we published this, and he used palynofacies, you know, to link that connection through the Sokoto Basin, or is it Ulemeden Basin, northwest towards the Tethys. So it's Tethys connecting all the way to the Atlantic. So yeah, you are right. I think there should be more of those studies. And then on the other side, on the eastern side, is the Benue Trough, you know, going the other way. So definitely there should be, I think, more opportunities to do palynological studies on those. So you are right, and I highly appreciate your thoughts on that.
Thank you very much, madam.
Thank you, Pa Jim Orif. We really appreciate you for that. Quickly, before I will invite the chairman. I think there's a question. I wish to find out if palynology can be used for provenance in sedimentology. That's the last question for this.
Definitely. I mean, that's one of the best uses, you know. In fact, the question from Mr. Ogunjobi about reworking, that's exactly what it is. You know, so with the palynomorphs in those lake ground sediments, we knew the origin of those, that some of the sediments came from the Eocene marine sediments. So provenance is one of the major uses of palynology, yes. So the answer is yes.
Once again, we really appreciate you for coming around. We now invite the chapter chairman, Dr. Chris Adegbe, FNMGS.
Thank you. Let me start by appreciating our guest speaker. This is our 5th webinar within the chapter. And when it came to my notice that we are calling her, I said, will she be available? And today is a reality. So I want to really appreciate you. If you have stayed back in OAU, I'm very sure that you will be within the chapter. You will be part of our resource person. And so we do appreciate for this insightful lecture, deep-seated, and a lot of information has gone out to people. And you can see that this lecture actually, in the course of our webinar so far, this lecture attracted more people. We, as the last count that I checked, we are like getting close to 70 on this page. And it's quite a wonderful presentation. Thank you, madam, for making it today. And I want to appreciate some of our senior Babas, you know, our living ancestors that have decided to join us. I can see the chairman of the League of Fellows of the NMGS, Mr. Jim Orife. He has always been part of our webinar since we started. I can also see Professor Mrs. Umeji, Mama, Professor Bisi Showumi, we really appreciate your gesture in joining us. Professor Nwajide, I can see you too. And the Vice Chancellor of Mountain Top University, Professor Ayolabi, I want to thank all of you and everyone that has decided to join based on the invite we give out. Professor Enyola, it's been a long time that I see Mr. Sheyi Ogunjobi. I can see your face new. You know, it has been like 10 or 15 years now. You are all welcome. Lastly, let me use this opportunity to remind us again of the conference, the NMGS conference, starting this weekend, Sunday, to be precise, in Ilorin. I'm looking forward to see all of you at that conference. Once again, on behalf of Ibadan chapter of NMGS, I want to appreciate Professor Francisca Oboh-Ikuenobe, sorry if I didn't pronounce it very well, for making our day. Thank you and God bless.